I'd like to use these two problems to introduce to you the idea of our next special case. So what I've got here is a binomial and a trinomial, and notice I have a term adding another term, and then here I have the first term squared, the last term squared, and the two terms multiplied together. Same thing over here, but I've got the signs a little different. So I want you to watch what happens when I multiply these out. When I take the a times everything, I get a cubed minus a squared b plus ab squared. Okay, now I'm going to take the b times everything. B times a squared is plus a squared b. B times this is minus ab squared. And b times b squared is plus b cubed. So whenever I put these together, I get a cubed. The negative a squared b, the positive a squared b cancel out. The positive ab squared, the negative ab squared cancel out. And I'm left with plus b cubed. It's interesting. The very numbers that I had right here and right here are now cubed, and everything else in the middle canceled out. Let's see what happens on this problem. A times a is a squared plus a squared b plus ab squared. Okay, the second row would be minus a squared b minus ab squared minus b cubed. So what happens is these terms cancel out once again. So what I'm left with this one is a cubed minus b cubed. So the special case that goes with this is called the sum of cubes. That's this one. This one is called the difference of cubes. This is something you didn't talk about in Algebra 1. So let's look at the pattern here. I had a cubed, b cubed. In this first binomial, I just had a and b, the number that was being cubed. In the second set of parentheses, I had whatever this was squared, and whatever that was squared at the end. And in the between, I had these two multiplied together. Same thing over here, a and b, so I had a squared, b squared, and in between, I had those two things multiplied together. And the signs, here the sign was the same, here it was the opposite, and here it was always positive. Notice this one was minus, so it was the same, minus. Then it was the opposite of minus, and always positive. So what we're going to do is try to take one of these and turn it into one of these. We're going to factor it. So let's start with one like x cubed plus 8. So first of all, I have to recognize that this is the sum or difference of cubes. So I have to decide, is this something times itself 3 times? And it is. The thing that you're timesing by itself 3 times is x. What about 8? Is that some number times itself 3 times? Yes, it's 2. So now I have the two numbers that I'm going to work with. Inside my small parenthesis, so I have a short parenthesis and a long parenthesis. Inside my short parenthesis, I'm going to put those very two numbers, x and 2. In the ends of the long parenthesis, I'm going to square each of those. So here I'm going to square the x, and here I'm going to square the 2, and 2 squared is 4. What I put in between, just like up here in our problem, was those two things multiplied together. So these two multiplied together would just be 2x. And now my signs are going to be the same as what's up here, the opposite of what's up there, and always positive. So we call that SOAP. The same, the opposite, always positive. Let's do another one. Let's try x cubed minus 27. So I have to decide first of all, is this a sum or difference of cubes? The answer is yes. The thing I'm cubing here is x. The thing I'm cubing here is 3, because 3 times 3 times 3 is 27. So if it's the difference of cubes, I'm going to have a short parenthesis and a longer parenthesis. Inside the shorter parenthesis, I have those two numbers that I'm cubing. Inside the longer parenthesis, I'm going to square those two numbers on each end. So x squared and 3 squared. In the middle term is those two multiplied together. And now to get my signs, I'm going to use SOAP. The same, the opposite, always positive. So if I multiplied this out, and you're welcome to do that, if I multiplied it out and got everything to cancel, I should start back, or end back with the thing that I started. Okay, let's make this one a little harder. Let's go x cubed plus 343. So I have to decide, is this thing a cube? So I'm going to grab a calculator here, show you how to find cubes. So if you're using the graphing calculator that's on, maybe you bought one, or maybe you're using the one that's on the apps on your Chromebook. If you open up apps, there'll be a graphing calculator on there. If I'm trying to decide if 343 is a perfect cube, I'm going to push the math button. And then after I push the math button, pops up a one that looks like this. See, I have the little 3 in front of the square root. When I hit it, and now it says cube root, because I'm trying to find something that happens 3 times. So I'm going to type 343 in and hit enter. And I find that the number that you take times itself 3 times is 7. That gives you 343. So I'm going to write that down. If you have the smaller TI-30 calculator, you'll have to find the little button that says X and then has a square root like that. And on that one, you're going to type in 3 square root 343. That's if you have that smaller calculator. But really, you should be just using the graphing calculator that's on your Chromebook app. So the number that I'm cubing is x and 7. So I'm going to have short parenthesis, long parenthesis, x, 7. This is going to be x squared and 7 squared. And in the middle will be those two multiplied together. For the signs, I'm going to use SOAP. The same, the opposite of the same, and always positive. Okay, let's do one more that's even more difficult. Let's do 8x cubed minus 125. So first I have to decide, is this a special case? Is this a sum or difference of cubes? So I have to think, what do I cube to get 8? What times itself 3 times give me 8, and that's 2, and x. What do I multiply times itself 3 times to give me 125? That's 5. So I have the thing that's going to go in my short parenthesis now. It's going to be 2x here and 5 here. At the beginning and ends of my longer parenthesis, it's going to be this thing squared. So when I square 2x, I get 4x squared. And at the back is going to be this thing squared, which is 25. And in the middle, I'm going to multiply those two, so I get 10x. And then the signs are the same as the problem, opposite of the problem, and always positive.